Hi, 7th graders, and thank you for joining me for Lesson 5.1c. Today we will be learning how to solve one-step equations with fractions. You will need your notes open to Lesson 5.1c. You will also need a pencil or a pen, and you will need a calculator. If you have all of these materials, you are ready for today's lesson. The goal when you're solving equations is to get the variable by itself, to find its value. In order to do that, you use inverse operations. So it's important to know that when you see addition, the opposite or inverse is subtraction. Because we're solving equations with fractions today, we are going to need to remember how to add, subtract, multiply, and divide fractions. So you are going to be seeing me refer to these steps throughout the lesson today. Okay, so let's get started with example number 1. Find number 1 in your notes. It is blank, so you will need to copy the example for number 1. N plus 5/12 equals 1/3. The goal is to figure out what is the value of the mystery n. So I'm going to begin by drawing a line down my equal sign just to kind of keep my work organized, keep everything nice and straight. I'm going to put a box around the variable n. My goal is to get the n by itself, to isolate it, to figure out what is the value of n. So take a look at what's been done to it. It looks like we've added 5/12 to our n. So we need to undo that with the inverse operation. The inverse or opposite of add 5/12 would be take away 5/12. I need to do that same thing to both sides of the equation. Now I see a plus 5/12 and a minus 5/12, or if you think of it as a positive 5/12 and a negative 5/12, these two are opposites, so they cancel and make 0. And I have n all by itself. I'm just going to bring down that n. Okay, so over here I need to figure out, well, what is 1/3 minus 5/12? And when you subtract fractions, we need to remember when we are subtracting, we want to be sure both fractions are improper or have a numerator and denominator, which they both do, and we need to find a common denominator before we can subtract. Okay, so I'm just going to rewrite these so that they're horizontal. 1/3, we started with 1/3, we're going to take away 5/12. Okay. So our common denominator between 3 and 12 here looks like it's going to be 12. We can change thirds to 12ths by multiplying by 4. So whatever we do to the bottom here, we multiply by 4. We have to do to the top, and we are going to get 4/12. And then I'm just going to bring down minus 5/12. This is going to give us the value of n. Okay, 4/12 minus 5/12. The denominator is going to be 12ths, but how many are there going to be? Well, let's look at the numerator. 4 minus 5. That's -1. N equals -1/12. There we go. That's the value of the mystery n. So if I were to plug that back up into the equation for n, -1/12, I could check on a calculator to see if I'm correct. And on a calculator, that ABC button right there, that is your fraction button. And you could type in -1/12 plus 5/12 and see that it equals 1/3. All right, we found the value of our mystery n. Let's go ahead to number 2. On number 2, we have a mystery w that we're trying to solve for. Okay, so you go ahead and copy the equation. I'm going to put a line down the equal sign just to organize my work to make it nice and straight. I'm going to box up the w. The goal is to get the w by itself. So I look at the side with the w. What's been done to it? -2.5. So what's the inverse of -2.5? Well, that would be +2.5. So I'm going to add 2.5 to both sides. The -2.5 and +2.5 are opposites. They're inverses. They cancel and make 0. So I have w all by itself. Now over here on this side, I want to add these two fractions. In order to add fractions, I need to be sure I have improper, which I'll need to change both of these, and then I need common denominators. Okay, so keep that in mind as we're doing this. Let's change 5 1/4 to an improper fraction. 4 times 5 is 20 plus 1 is 21/4. Then we're going to add 2.5. 2 times 2 is 4 plus 1, I get 5/2. Okay, we need common denominator. Looks like between a 4 and a 2, our common denominator would be 4. So I'm going to multiply the top and bottom here by 2 to make an equivalent fraction. So I'm going to end up with 10/4 plus the 21/4 equals w. All right, so we got fourths and fourths. 21 fourths plus 10 more fourths. We know we're going to get fourths. How many? Let's add the numerators. 21 plus 10, 31 fourths equals our mystery W. There we go. And we can just leave our answer as an improper fraction. And we know that if we put it back up here for W, 31 fourths, we could always check this on a calculator. Does 31 fourths minus 2.5 equal 5 and 1/4? That was our mystery W. So here we were doing addition and subtraction with fractions. We had to find a common denominator and change them both to improper. So those are our steps with add and subtract. Now in our next examples, we're going to see multiplication. We're going to see a fraction that is attached to a variable. I'd like you to first in your notes find this on the left side column of your notes. What happens when you multiply a number by its reciprocal? So we're just going to take a step back real quick before we hit number 3. All right, we know reciprocal means that we take a numerator and denominator and flip it. So what would happen if I took the number 2/3 and multiplied it by its reciprocal? So let's just multiply it by the reciprocal of 2/3 would be 3/2. What would happen here? Let's just multiply straight across. The top and the bottom, I would get 6/6, which we know 6 divided by 6 is the same thing as 1. All right, let's look at the next one, -7/4. What if I multiply that by its reciprocal? If the fraction's negative, the reciprocal is going to be negative also. So this would be -4/7. Now, if we multiplied straight across, we know a negative times a negative is a positive, and I'd have 28/28, which is the same thing as, of course, 1. The last one, 1/5. If I multiplied it by its reciprocal, that would be 5/1. And if I just went straight across and multiplied, I would end up with 5/5, which also equals 1. What are you noticing? Every single time when you multiply a number by its reciprocal, you get 1. Oh, there's a fun dancing 1. Yeah, you get 1. So when we take a number and multiply it by its reciprocal, our product or our answer is always going to be 1. So now let's take a look at number 3 and 4. Okay, before you write anything in your notes, so don't write anything down. I want you just to take a look at this example number 3 here. It says 3/4 times n, because they're stuck together with an invisible operation, multiplication, equals -15. Now, being that we have 3/4, a fraction connected to a variable, they're attached, right? Being that this is multiplication, I can undo this with the inverse operation. Absolutely. I could divide both sides by 3/4. That would work. And you probably learned to do that in 6th grade as well. But think about this. If I took 3/4 divided by 3/4, of course I'm going to get 1. I'm going to get 1n. I'll have the n isolated. But look over here. I have -15 divided by 3/4. What happens if I do that? -15 divided by 3/4. I would have to change divide to multiply and then flip the second fraction to 4/3. I then would change the problem to multiplication. So what I could do then is simplify before I multiply, divide by 3 here, divide by 3 here, and I would end up with n equals -20. Okay? But notice that by dividing both sides by this fraction, I end up multiplying by the reciprocal. Okay, quite a few steps going on here. All right, we're going to try this a little bit different way. Now, notice how when I divided by 3/4, I got 1. Anytime you take a number and divide it by itself, you get 1n, which is our goal. Now, let's do the real number 3 in our notes. Okay, the real number 3, I want you to copy down, looks the same as before here. 3/4 times n equals -15. We're going to try and find the value of the mystery n. Okay? So I'm going to draw a line down the equal sign. Now I'm going to put a box around the n. The goal is to get the n by itself. It's being multiplied to 3/4 because it's attached. It's stuck to it with its invisible operation multiply. Yes, I could undo this by using the inverse operation, division, like I just showed you before. However, I want to show you a different way. Think about when we divided by 3/4, we got 1n. How else could we get 1n? What else could I do to 3/4 that would get me 1 besides division? Ah, could I multiply by the reciprocal? Yeah, what would happen if I multiplied by the reciprocal 4/3? What would I get for the product here? 1. Absolutely, right? 4 divided by 4, this numerator and denominator both have a common factor of 4, they divide. And 3 divided by 3, right? They both divide, they have a common factor of 3. They cancel out and I get 1n. Awesome. See, I can multiply by the reciprocal. That means I have to do the same thing over here. I'm going to multiply by 4/3 over here as well. Now let's just take a step back real quick. Isn't that what we did over here? Didn't we multiply by 4/3? Yeah, we absolutely did here in this same example. So I'm just saving myself the step of dividing and having to keep switch flip. Okay? So now when I multiply fractions, I want to keep in mind I need to be sure that they're both improper and simplify before I multiply. So I need this 15 to become improper. Now let's simplify before we multiply. 3 and 15 are both divisible by 3. Divide by 3, I get 1. Divide this by 3, I get 5. And then I'm taking negative 5 times 4, and that's going to give me negative 20 for my answer, which is the exact same answer we got over here when I did this one, negative 20. But instead of dividing by 3/4, I just went right ahead and I multiplied by the reciprocal. Okay, this is what we need to be able to do in 8th grade algebra, so we're practicing now. All right, so anytime I see a fraction attached to the variable, I can use the reciprocal to undo it. All right, let's go ahead and do number 4. Here in number 4, we have negative 1/3 attached to the variable, right? Even if this was a positive 1/3, do you see how they're attached together with an invisible multiply operation? Okay, so we got negative 1/3 times x equals 1 1/9. All right, so I'm going to draw a line down the equal sign. I'm going to put a box around this x. My goal is to get the x by itself. I see how it's stuck to 1/3. It's attached. Yes, the inverse operation of multiply is to divide. However, I'm going to use that reciprocal trick. I'm going to multiply by the reciprocal. So multiply. Now, if this is the fraction negative 1/3, its reciprocal will also be negative. So negative, and then let's flip 1/3, and we have 3 over 1. Okay, and then the same thing to the other side. We're going to multiply by negative 3 over 1. Okay, so now do you see how a negative times a negative, that's going to give us a positive. The 3 in the numerator and the 3 in the denominator both have a common factor of 3, so we can divide by 3 and get 1. See how all of this, when you multiply, makes positive 1. Okay, positive 1x, but I only need to drop down the x. I don't need the 1 in front of it. Now over here, when I multiply fractions, I need to be sure that they're both improper before I multiply. So let's change the 1 and 1/9. 9 times 1 is 9 plus 1. This would be 10/9 times negative 3 over 1. Okay, then simplify before I multiply. A 3 and a 9 are both divisible by 3. Divide by 3, I get 1. Divide by 3, I get 3. Now let's multiply straight across. I'm going to bring down x equals, so we have a little bit more room. 10 times negative 1 in the numerator is negative 10. And 3 times 1 in the denominator is 3. And I get the answer of negative 10/3. So there is my answer for my mystery x, negative 10/3. So in both examples, 3 and 4, I had a fraction that was attached to the variable. And to undo that, I multiplied by the reciprocal. Pretty cool, huh? Okay. We're going to move on to number 5 and 6, where we're going to see some real life application problems. We're going to see how we can write an equation to represent a situation and solve our equation. In number 5, Jesse is baking his favorite chocolate chip cookies. The recipe calls for 2 1/3 cups of semi-sweet chocolate chips. If he already put in 1 1/2 cups into the batter, how many more cups of chocolate chips should he add to the batter? Well, this is our question. How many more cups of chocolate chips does he need to add to the batter? So our answer for our question will look like Jesse needs blank cups more. All right, so let's look at what we have in our problem here. Let's look at our numbers. The recipe calls for 2 1/3 cups of chocolate chips. This 2 1/3 is representing the total chocolate chips that Jesse needs for the recipe. He already put in 1 1/2 cups into the batter. And we're asked how many more cups will he need to add to the batter. So he already has 1.5, and he's going to be adding some more to get a total of 2 1/3. So I'm thinking an addition equation. Are you thinking an addition equation? Just because of that word add. Well, it's asked us how many cups. So let's use the variable c, and you could pick any variable you want. We're just going to use the variable c to represent how many more cups. Okay, so let's tell this story with an equation. Jesse already has 1.5 cups. 1.5 he already has. We want to know how many more he needs to add. How many more cups does Jesse need to add to get a total of the 2 1/3 that he needs? All right, does this equation tell us the story? He put 1.5 cups in. How many more does he need? That's the question mark. That's the mystery to equal a total of 2 1/3. Generally, you'll see the total on the right after the equal sign. Okay, we have our equation that tells us the story, and now we are ready to solve our equation. All right, let's solve it. Let's figure out the answer to this. My goal is to get the C, the mystery cups. So you see how it's added to 1.5? I'm going to take away 1.5. I'm going to do that to both sides. So that's going to 1.5 minus 1.5 gives me 0, and I have C all by itself. All right. Now over here, I have 2 1/3 minus 1.5. Remember, when you subtract fractions, we want to change to improper, and then we need a common denominator. So change to improper. 2 1/3. 3 times 2 is 6, plus 1 is 7/3. And then we want to subtract or take away 1.5. 2 times 1 is 2, plus 1, 3/2. Okay, so we've got improper fractions. Now we need a common denominator. So common denominator looks like is going to be 6. So I'm going to change these into 6 by multiplying by 2 to get that to be 6. Here I'd have to multiply by 3, top and bottom. So I end up with 14/6. Take away 3 times 3 is 9/6. So if I have 14/6 and I take away 9/6, that's going to be 5/6 equals C. So I've figured out the mystery cups that Jesse still needs for the recipe in order to make it. 5/6. So Jesse needs 5/6 cups more. And there's my answer. All right, we figured it out, Jesse. We're going to help you out with your baking. All right, there we go. We have number 5. All right, on number 6, we're asked here if the weight of a package is multiplied by 5/7, the result is 40.5 pounds. Find the weight of the package. So I put a box around our question, find the weight of the package, and here I'm going to answer the question in a sentence. The package weighs blank pounds. This is the abbreviation for pounds. We're asked to find the weight of the package. So maybe we want to use W for our mystery weight. You could use any variable that you want. All right, let's read the situation. If the weight of the package is multiplied by 5/7, so we want to take this unknown weight and multiply it by 5/7. Would I write it as W times 5/7? That's right, it's correct. However, whenever we're multiplying a variable by a number here, we want to change the order and put the number first. So we want 5/7 times W. There we go. There's the weight times 5/7. Okay. So the weight of a package is being multiplied by 5/7. There we go. And it says the result is 40.5 pounds. Result means the answer. It equals 40.5 pounds. So the result is equal to 40.5. Now I have the equation. So let's check it again. The weight of the package is being multiplied by 5/7. Yep. And the result is equal to a total of 40.5 pounds. Awesome. We've got it now. So we need to figure out the mystery weight of the package. What is being multiplied to 5/7? Okay, do you notice how in this problem I have a fraction attached to the variable? How do we undo that? Not division, although that would work. What's the trick I taught you? What can we do? We can multiply by the reciprocal. So I'm going to multiply by 7/5 over here and over here on this side. Now what's going to happen here? 5 and 5 both have a common factor. You can divide them both by 5, changing them to 1. Same thing with 7 and 7. Divide by 7, change them to 1. Do you see how you have 1W? Yay! Okay, over here now when we're multiplying fractions, We want to be sure that they're improper. So we have to change this one to improper. 2 times 40 is 80 plus 1 is 81 halves times 7 fifths. Then we check if we can simplify before we multiply. So let's look. 2 and 7, do they have a common factor? No. 81 and 5? No. How about 81 and 2? I look top and bottom. No. 7 and 5? No. There's no simplifying that I can do. So I'm just going to multiply straight across. This is where I'm going to need my calculator a little bit to type in 81 times 7. So W equals 567 in the numerator and 2 times 5 in the denominator. Now, does this make sense? The package weighs 567 tenths pounds. No. Remember that when we have a word problem or a real life situation, we want to make sure our answer is a mixed number because that's going to make a lot more sense. So we want to change this into a mixed number. So we want to actually take the 567 and divide it by 10. So I'm going to go 567 divided by 10 right here. So I'm going to use my calculator to help me. I'm going to take 567 divided by 10. I want my answer as a fraction, but this is going to help me get the whole number. Do you see 56.7? 56 is the whole number. So the 10 is going to go into that 56 times. Now 56 times 10 is just 560. And I subtract, and I get 7. That's my remainder. Now remember, 10 is your denominator. That didn't change. 10 is still the denominator. But how many pieces do we have left? We have 7 tenths. And you can see here that when I divided 567 divided by 10, I have 56.7. That 56.7, that is read as 7 tenths. 0.7 is 7 tenths. So this makes much more sense. The package weighs 56 and 7 tenths pounds. Wow, that's a lot of weight for a package. That's going to be a pretty expensive package if you plan on mailing that. All right. Okay, let's go to our summary. Let's do a little summarizing. The new thing that we saw today was with multiplication, we saw a fraction that was attached to a variable. So whenever we see a fraction attached to the variable, yes, we know that we can sure undo it with its inverse operation, which is division, but we learned something new today. We learned that we can undo this fraction by multiplying by the reciprocal. And that's what we want to try and practice to get us ready for algebra next year. So anytime we see a fraction attached to the variable with multiplication, we're going to undo it by multiplying by the reciprocal. Thank you so much for joining me for today's lesson 5.1c. Have a great day.